The real shift this week is that vision systems are starting to behave like generators of structured reality, not just classifiers or captioners. One model can now preserve scene geometry across long multi-view videos. Another can retrieve the web from screenshots instead of flattened text. And a third is collapsing detection, depth, segmentation, and pose into one generative interface. That matters because it points to a future where multimodal models keep layout, 3D consistency, and spatial meaning intact. The interesting part is how these systems make that practical and where they still break. Let's explore the first paper, MV forcing long multi-view video generation via 4D grounded spatio-temporal self-forcing. MV forcing from researchers at the Hebrew University of Jerusalem and Cornell University tackles a gap that existing video diffusion systems such as SynCam Master and self-forcing leave open, generating long videos that stay consistent across multiple camera viewpoints. The key idea is to combine temporal autoregression with view sequential autoregression, while using Cut3R as a 4D geometric bridge that reconstructs a persistent scene state from previously generated frames and renders a viewpoint-specific geometric prior for the next view. The student model is distilled from a bidirectional SynCam Master teacher with distribution matching distillation, then trained with spatio-temporal self-forcing and a joint denoising regime, so the first view can be generated from text and later views can be generated autoregressively without a fixed temporal window. On the SynCam video benchmark, which contains 3,400 synthetic scenes captured from 10 synchronized cameras, MV forcing reaches strong long horizon performance at 3 views and 162 frames, improving camera accuracy to 3.72 rotation error and 8.41 translation error, while raising cross-view synchronization to 243.63 matching pixels and 89.88 clip V in the synthetic setting. Scaling is notably stable. Performance remains close to constant from 2 to 5 views, and across 81 to 648 frames, the method preserves camera metrics with only mild temporal degradation. Runtime is also practical, with a 4-step causal student running in about 70 seconds for 2 views at 81 frames and using 23 GB peak VRAM, roughly a 5-time speedup over the 50-step SynCam Master baseline. Let's explore the second paper, PixelRag Web, Screenshots, Beat Text for Retrieval Augmented Generation, PIXEL RAG from UC Berkeley, Princeton, EPFL, Databricks, and Renmin University argues that web retrieval should operate in pixels rather than parsed text. The system renders Wikipedia and news pages into screenshot tiles, indexes them with Qwen3, VL, embedding, 2B, and feeds retrieved images directly to a vision language reader, eliminating HTML to text parsing. On the full 7,134,778 article Wikipedia corpus, this produces about 30 mtiles and an offline pipeline that completes in about 2 days on one machine. Across 6 benchmarks, including natural questions, NQ tables, simple QA, Search, encyclopedic VQA, and live VQA, pixel retrieval beats both no retrieval and text-based RAG. On simple QA, it reaches 78.8 accuracy and 83.8 recall at 3, compared with 71.6 and 77.4 for Trafalatura. The gains are strongest on structured content, where tables and info boxes are preserved visually instead of being flattened. And on EVQA, it improves accuracy by up to 18.1% over text baselines. The paper also introduces synthetic contrastive training with LLM-generated queries, dynamic hard negative mining, and LoRa fine-tuning of both the ViT and language backbone. Beyond accuracy, Pixel Space RAG enables compression. At 2 times downsampling, a fine-tuned reader nearly matches native resolution while cutting visual tokens roughly in half, and the authors report up to 3 times token cost reduction overall. The broader claim is that as VLMs like Qwen3, 5, Qwen3, 6, and Llama 4 improve, screenshot native retrieval becomes both more accurate and more efficient than text-centric pipelines. Let's explore the third paper, Vision as Unified Multimodal Generation. Vision as Unified Multimodal Generation from SenseTime Research and collaborators at Nanyang Technological University reframes computer vision as a single multimodal generation problem inside a unified multimodal model rather than a collection of task-specific heads. Built on the Bagel, 7B, MOTI backbone, SenseNova Vision, converts heterogeneous supervision into instruction response pairs spanning text, image, and mixed text-image outputs, and trains on the SenseNova Vision corpus, including the released SNVC50M subset with 50 million converted examples. The model covers structured perception, dense geometry, segmentation, and multi-view 3D, using standard cross-entropy for text outputs and rectified flow for visual outputs, with SIGLIP 2 inputs up to 980 pixels and multi-view samples capped at 10 views. On structured visual understanding, it matches the best detector on COCO Common at 56.6 and reaches 80.5 on RefCOCOG test. On dense geometry, it obtains 4 ABS rel and 98.1 delta, 1 on NYU 2 depth, plus 12.8 mean error, and 68.9% delta, 1125 on ScanNet normals. For segmentation, it reaches 63.2 GIOU on reasoning segmentation and 73.9 MIOU on interactive segmentation with point prompts. In multi-view geometry, it records 87.9 F1 on 7 scenes reconstruction and 80.1 AUC at 30 on CO3 DV2 camera pose. The paper's central claim is that native text and image generation can unify symbolic records, dense maps, masks, point clouds, and camera poses without architectural specialization, while preserving broad multimodal abilities such as 79 on MMVP and 0.85 on Retrieval. That's a wrap on today's AI paper highlights. Thanks for watching.